Morning participants, and we are going to start shortly today's webinar on Glacial Lake outburst flood in Himalayan region. Good morning, dear participants and distinguished speaker and our panelist. I welcome you on today's webinar, that is the Glacial Lake outburst flood in Himalayan region. In this context, we are having three eminent speakers and world-renowned expert in glaciological field. So today we are having Dr. Anil Bhushan V. Kulkarni. He is distinguished scientist from MHA Center for Climate Change in Indian Institute of Science, Bangalore. And also we are having Dr. Pankaj Kumar. He is associate professor in Delhi School of Economics, Delhi University. And also third speaker is our ex-colleague, Mr. Anil Kathait. He is technical officer in EM VHS CDC India. Now, before going to start, I will say a few words about the GLOF, that is a glacial lake outburst flood. And glacial lakes are common in high elevation of glaciarized basin. They are formed when glacial ice or moraines or natural depression impound water. There are varieties of such lakes ranging from meltwater ponds on the surface of glacier to large lakes inside valleys. And it is dammed by a glacier in the main valley. These lakes normally drain their water through seepage in front of the retreating glacier. The moraine creates topographic depressions in which the meltwater is generally accumulated, leading to formation of glacial lake. When the lake is watertight, meltwater will accumulate in the basin until seepage or overflow limits in the lake levels. So in India, nowadays, a lot of sensitive glacial lakes are there, which are dangerous. In Tista River Basin, we are having 285 glacier. Out of them, 14 potentially dangerous glacial lakes are there. Similarly, in Himachal Pradesh region, out of 2554 glaciers, 22 potential glacial lake outburst lakes are there, which are dangerous. In Uttaranchal also, more than 127 are identified from satellite, and it is there. So although it is identified, a lot of dangerous glacial lakes are there in Himachal region. Now, I will not go details in keeping in view the paucity of time. Now our objective is, that is why the danger of glacial lake outburst is increasing every year, first thing. Second thing, that what is the reason of glacial lake outburst flood, and how can we reduce the impact of the glacial lake outburst flood. So with this objective, now our renowned professor, that is Surya Prakash Sab, is with us. He is head of our department division. Now a keynote address will be given by him. So before hand over the stage to him, so I'll say a few words about him. That is Professor Surya Prakash. So Dr. Surya Prakash is presently working as a professor and head of geometeorological division, geometeorological risk management division, and also he's a head in CBRN, Industrial and Cyber DRR division. He's a team leader of World Center for Excellence on Landslide Disaster Reduction and faculty in charge, and 8 specialized centers are there. He was a team member of NDMA in joint team to study the recent Uttarakhand disaster that was the last year on 7th February 2021 to suggest measures for disaster risk reduction and resilience. He was member of IMCT during the pandemics. He was also nodal faculty for 9 central ministries for coordinating disaster management activities, including Ministry of Petroleum, Natural Gas, Coal, New Renewable Energy, Communication, Mines, Shipping, Labor and Employment, and Parliament Affairs and Northeastern states. Formerly, he was head in Knowledge Management Communication Division and former head of Hydrometeorological Division and former administrator of NIDM GFDRR. And he was coordinator for the Indo-Japanese Action Plan on Landslide and Disaster Management as a part of the security declaration between Government of India and Japan, signed by the Prime Minister of both the countries. He was member of Indian delegation on third World Conference on Disaster Risk Reduction. That was on 14th to 18th March in 2015 at Sendai, Japan. He has organized more than 300 national, international training, webinar, workshop, and conferences. He has been recognized as qualified professional geologist by Indian Bureau of Mines, a licensed HAM by Department of Telecommunication, and member of International Consortium on Landslide, Japan. He is national coordinator of IAPG, that is International Association for Prompting Geoethics, Italy, in India. And he has been founder chairman of the Community-Based Disaster Risk Management Society in India. He has been the recipient of UGC's National Merit Scholarship and CSR Fellowship during his studies. He obtained doctoral degree, PhD from IIT Roorkee, and did specialized training on climate and geohazards risk management in University of Geneva, Switzerland. And he was awarded academic fellowship by World Bank, Washington, and received various international grants from Swiss Agency for Development and Cooperation, Bern Royal Government of Netherlands, Japanese Landslide Society, National Taiwan University, etc., for the participation in international activities. He has received the Scotch Order of Merit Award for awareness creation and sensitization in disaster management through e-learning. After qualifying in India Best Governance Project for the year 2014, he has made more than 150 publications as paper, book, reports, articles. He is member of editorial board for several journals and member of several professional societies as national and international level. He is presently editor in Journal of Disaster and Development. So this is his introduction. Now with this, I'll hand over the stage to Professor Surya Prakash, so for sharing his keynote address in front of our participants. What do you, sir?
Thank you, Dr. Haldar. Am I audible?
Yes, sir, you are audible.
I'm sorry, being away from Delhi, I'm just addressing through my mobile. Maybe the signals are little poor because of the network. Anyway, my basic purpose of addressing this webinar was that the changing climatic conditions are changing the frequency, intensity, and distribution of the various hazards, including the glacial lake outburst floods, landslide dammed lake outburst floods, landslides, flash floods, and other such related phenomena due to varying patterns of the rainfall distribution in terms of its intensity as well as the onset of the rains, particularly during the monsoon periods. So, as said by Professor Dr. Haldar, that these changing climatic conditions are also leading to change in the annual average global temperatures and also the sea level rise due to the melting of the glaciers, resulting into sometimes the submergence of the island states, which are also a major concern at the global levels. So in this particular webinar, the focus will be primarily on the glacial lake outburst floods. And we have distinguished experts like Dr. Anil Kulkarni ji, who have done a lot of work in this area and has very long experience and currently associated with the Climate Center at Indian Institute of Science, Bangalore. And also Dr. Pankaj Kumar ji from Delhi School of Economics, as well as Mr. Anil Kathat, who has also worked quite a lot since last about more than 10 years in the field of disaster management. All these experts, they will be sharing their rich knowledge, experience, ideas, innovations, and the available technologies, tools, and techniques for disaster risk assessment, prevention, mitigation, preparedness, efficient response, and recovery. So I hope the delegates and the participants of this program will get very much benefited from their deliberation, and would urge all of them to kindly make it bilateral discussion and interaction oriented program, and do ask questions to the distinguished experts who will be actually sharing their presentation with all of you. So maybe you may need to know certain things beyond what is presented by them, or your requirements may differ. So it is better to ask questions to know what you require. So thank you very much for this, and I wish you all safe, healthy, good quality life on an equitable, justifiable, and right-based manner with good fraternity amongst all of us. So nowadays we are dealing in a multi-hazard perspective as per our national policy on disaster management, following its same for zero casualty, disaster-free, and resilient nation. And I wish all our efforts together as a team. Team means together each achieve more. We'll be able to reach to our destination of this zero casualty and disaster-free resilient nation. As Vivekanand ji has said, that stop not till the goal is achieved. So we have to arise awake and stop not till the goal is achieved for the national policy on disaster management, which was released way back in 2009. With these words, I thank you all and wish you all the best, and to the all the organizers and host team, moderator, as well as the distinguished experts, delegates, and the participants. And I welcome you all on behalf of NIDM and on my personal behalf. Thank you very much. Back to you, Dr. Haldar.
Thank you, sir. Very good message you have given, and nicely I have elaborated. Now it is the time for our technical session. That so far our first speaker, he could not join due to the problem in his computer. So he's trying his level best. If it takes time, then in that case, I would request Dr. Pankaj Kumar to get ready. In the meantime, let me have talk with him. In the meantime, Dr. Pankaj Kumar, could you hear me?
Yes, I can hear.
So please get ready. I'll convey within a minute, please.
Will it possible for you to share my slide? Because I'm also using my mobile phone. Dr. Haldar sir, may I request you to share my slide?
So I have to share. From here that your PPT.
Yes, sir.
Just 1 second, I'll confirm. Let me have a talk with Dr. Kulkarni. Then I'll tell you.
Okay, fine.
Now, some problem is there due to the paucity of time. I request Professor Dr. Pankaj Kumar to continue. So, in the meantime, when he will join, so we'll offer him also after the completion of Dr. Pankaj Kumar. Now, I'll share a brief about Dr. Pankaj Kumar.
So, thank you very much, Haldar sir, Dr. A.L. Haldar sir, I outset, I just like to thank Professor Surya Prakash sir, head of the GMR division, for giving me this opportunity to share my work among the August gathering. And whatever the little work we have done on Glacial Lake outburst flood and how it is a threat to the mountain sustainability, I will try to dwell upon the issue. And it's a very pertinent one. And nowadays, you know that because of this the warming pattern and all, we have some increase in the surface temperature in the mountain, and because of that, we have also the snow cover is declining, and that snow cover decline is resulting into formation of glacier lakes at the snow out position, and these glacier lakes are gradually increasing their size because of feeding water from the melt of the glaciers in the nearby area, and that is resulting into the increase in the area and increase in the volume of water into these glacier lakes, and because of some physical causes or some disturbances, the moraine dam, which basically protect the water, sometimes having developed cracks because of the earthquake or maybe pressure on water because of the some other geological happenings, and that can result into a mass exodus of water from that area, from that lake, and that will affect the whole livelihood pattern of the downstream population. So my topic today is to see the GLOF in the Western Himalaya, and I'm going to talk on some of the case study of Lahaul and SPT and how it is a threat to the mountain sustainability. Next slide, sir.
Just 1 second. Yes.
My framework of presentation is basically I will touch upon the study area, and then introduction part, I will try to review some of the climate change studies done in my study area to sensitize the people that this is now reality. We can't say that the climate variability is there. It is now reality that climate change is happening, and because of that, there is snow cover change is happening, and the snow cover change is resulting into the formation of glacial lake, and sometimes it is a potential danger for the people living in the area, and that is why we have to go for monitoring, assessing the threat or risk or vulnerability associated with this glacial lake outburst. Next slide, sir. This is the study. This is my study area is having basically it is covering the portion of Shivalik Hills in the south to the Trans Himalayan zone in the north, and it has a very typical altitudinal zonation that we start from 300 meters in the plains of Kangra and we reach to the 7,000 meters in the high hills of Lahore and Spiti. And I am focusing more on in this presentation. I am giving for a case of Lahore and Spiti. So this the study area. Next slide, sir. Himachal, you can easily see here the altitudinal division, and also some of the inventory of the lakes we did in the past. We have depicted into the right hand side here, the this where we have the Lahore and Spiti district map, and we are positioning, giving the position of two major lakes, that is lake number 15 and 17, which we have given the name, and that is the potential threat into that area which we will dwell upon. Next. We start with this Prime Minister's 10-point agenda on DRR, and Agenda 5, which is the main topic on which this webinar is organized, is it's clearly mentioning leverage technology to enhance the efficiency of disaster risk management effort, and it is saying that you have to go for creating e-platform to map expertise and resources on highly specialized aspects of disaster response to increase the efficiency of early warning system and to somehow minimize the hazard through the application of technology. Next one. The background is that the global warming and global climate change during the first half of the 20th century has brought a tremendous impact on the high Himalayan glacier environment. Many of the glaciers melted rapidly and gave birth to the origin of large number of glacier lakes. As the glaciers continue to shrink and frequency of landslides, ice, avalanche, and floods increases, some of the most devastating impacts in the form is the glacial lake outburst flood. So next slide, please. Next one. Okay, so I reviewed some of the climate change and Western Himalayan scenario and came out with the Brohan et al. 2006 and Diod et al. 2012, Dash et al. 2007, Dimri and Dash 2012, and Bhutiani et al. 2007. They have taken the climatic parameters, and on the basis of that, they have tried to predict how much increase in temperature is expected into the Western Himalayan region with the different time framework, and someone has come out, but everyone is pointing out that around 0.5 degrees Celsius increase in the minimum temperature we are getting. Some is saying, so this depend on the temporal data what they have taken. Bhutiani has come out with the result for decadal change, and he is indicating that 0.16 degree per decade during the century. Next slide, sir. So I'm very much convinced now that it is not variability, it is a climate change scenario situation, and that is creating a suitable background where
तो
the glacial lakes are forming
सर ज्वाइन
and
कैसे ज्वाइन
that
हुआ ना नहीं?
next, next year. So scientific evidence for warming of the climate system
हाँ
is
हाँ ठीक है,
unequivocal.
हमने शुरू कर
Uh,
दिया, कल 10 मिनट में खत्म हो
that
जाएंगे
is
आप
for
कैसे
Intergovernmental Panel on Climate
राइट?
Change. So 97% of climate scientists agree that the climate warming trends over the past
सुना
century
नहीं
are
दे रहा है
very
सर,
likely
प्रॉब्लम.
due to human activities, and most of the
ओके प्लीज.
leading scientists organization worldwide had issued public statement endorsing this position. Next slide, sir. And this is the area where I work. Basically, I consider only the snow and try to see the dynamics of snow cover. Yes, please. Next slide, sir. So slide is not coming.
Just 1 second, please. Not moving?
No, not moving, sir.
Just 1 second, please.
The relationship between the climate change, glacial melting, and GLOF, and we see that the greater absorption of heat energy by exposed surfaces, resulting into increase in temperature as a result of the change in the average temperature. And this is creating a situation where the glacial and snowpacks are melting, and lake formation is taking place. Increase in the surface area and volume of glacial lake is happening, and that glacial lake is creating a situation that they can be a potential GLOF. So we have to monitor all these GLOFs which we are identifying and doing some study on that. And government is also working in this. SASA is working on in this area. So many scientists are working in the. Anil Kulkarni sir is still very actively engaged in the area and having so many publications. So the people we should communicate our findings to the organization. Those are taking the initiative to monitor in detail these lakes and how we can minimize or mitigate the impact if there is a risk or there is some vulnerability posed by these lakes. Next slide. So this is my study area which for whole Himalaya, and I have taken the TM and ETM for 1989 and 2011. But the recent study also we have done, and I'm going to show that one how the snow cover is changing into this area. So the next slide, please. So in 1989, you can easily see the coverage of the snow, and in 2011, you can easily see the coverage of the snow, and it can be easily identified that the snow is declining in this area. You can see the snow out position where we have Samut glaciers, we have the Sark glaciers near the Kunjamla, Chota Singri glacier in the background. Next slide, sir. Okay, so some of the status of different river basins of Himachal, Himalaya. So the glacier lies in these river basins are indicating, except for Miyar River Basin, where we have 80 glaciers. Those has been studied between 1962 to 2001. 2001, they have shown some of the glaciers are not showing any trend of decrease or increase, but all other basin, either it is Spiti Basin, Parvati, Chandra, Baspa, all are showing different rate of decrease of glaciers, and so we can come out with the conclusion that the glaciers are having some decrease, showing the decreasing trend, and that is the situation worry. Next slide. The next slide, please. Yes, here we are just showing you here. These are the area where we have so many the changes noticed into from 2000 1989 to 2011. Around 8% of the total geographical area in decline. And that is a rough estimate and depends on the data set, so depends on the time also from which we have taken the satellite image. But definitely it is giving a sign and signal that it is giving a sign and signal that there is some issue, and for which we have been. Next slide, sir. So the snow cover for 1990, 2010, and 2020 is clearly indicating that the snow cover is declining in my study area. You can easily see by your looking, and you can visualize these things that around 20% of the snow cover is again. I am saying that this is also it depends on what the source we have for the satellite image time for which we have taken the satellite image. All this can write the result. There is a sign that the area is having issue with the snow cover is declining. Next, we tried to see our land surface. Next slide, sir. One of the hurdles which he was there in the my study area, and I interacted was also with the view that snow is declining. You can easily see if the cover is declining and if the global warming is happening, what is the changes taking place in that area. So the agriculture is up in a big way in Lahore and the Spiti Valley, and you have the chance to visit the area, you can easily see this fact that so many agricultural lands has been in a Spiti also. The apple orchards have come into a big way. Next, sir. Next slide. We have seen the land surface temperature change, and we tried to look into this if the land surface temperature is increasing, is in the next. So in this bracket highlighted area, you can see in Spiti Valley how we have is around 6% of change increase in the greenery we have noticed in the area, and that paper was published in Journal of Mountain Science. Next slide, sir. Yes, this is, you can see 604% increase in area in the vegetation has been noticed, has declined to minus 24% during 1990 to 2015. Next slide, sir. So because of all these things, because of the warming, you can get this images of change, which is there on the NASA website, and that is clearly indicating in the Tibet Plateau, because of the temperature warming and receding of the glacier lakes are increasing their size, and new glacier lake has come up into this area, and that has been mapped, monitored. So from 1987 to 2021, a great change has been noticed. Now, so this is not only in our area, but everywhere globally you can find that because of the global temperature change, we have increased in the number of lakes and also the area of the lake. Next slide, sir. The same you can find from the images of change of the NASA, the exceptionally early ice melt of Greenland. So 2014 there was no any glacial lake on the snow, but now we have seen so many supraglacial lakes there. Next slide. Next, yes. In the new, you can find here how the sinking of glaciers is taking place, and because of that, we have so many glacial lakes coming up into that area from 1990 to 2070. Next one, and this is the formation of glacial lakes, how it starts and how it develops in four-phase manner. The glacial lakes are developing at the snow out position, and moraine dam is basically stopping the water and creating a situation to make it as a lake. Next slide, sir. So you can find here one cross-section profile of Samudra Glacier Lake, and from far near about Chandata Lake, I have taken this photo of ablation point of the Samudra Glacier Lake, where there is a glacier lake that is in Google Earth image. You can easily see here, and this is a typical cross section profile of the globe. Next slide, sir. Next, this is the Chandata Lake near the Samudra Glacier Lake. Next, sir. Next slide, sir. Next, sir. Next slide, please. Yeah, we can escape this one, sir. Next slide, please. Yeah, I have taken this clock and Matthew's formula to come out with the Q max, how much water is there, and if there will be some outburst, how much water will be released. So we calculated using this formula all the glacial lakes which we identified into the area. Next slide, sir. So these are the glacial lakes for which we have come out with the latitude, longitude, area, average depth. So average depth we have taken from the publication, one of the publication, the average depth we have taken, and then we came out the Qmax, and we identified the 2-3 lakes for which we studied in detail. Next slide, sir. These are the lake. This is the recent lake inventory we perform in the area. Around 200 lakes we identified into this whole Kinnaur, Lahore, and Spiti and Chamba, and we identified some of the uh, lakes which are growing in their size. And out of these, two are very prominent, for which we will see. You will see the data. Next one, sir. Yes, and we tried to identify how vulnerable these lakes are, or how much potential threat we have. So low, moderately low, medium, moderately high, and high. We identified. Next one, sir, please. And we focused on these two lakes. One is the Gipangath, another is the Samut Tapu Glacier Lake, for which we started studying this lake from land image of 1976 to till now, and you will find how the aerial change has been taking place into in these two glacier lakes. Next slide, sir.
Is it moved or not?
You can Yes, you can find this one from August 89 to October 2020, and we have these two lakes. One is Vipanga, another is Mutapu. It has increased the area and the volume in many fold, and that is why we have to focus on these glacier lakes to further study them in detail. And if there is any threat, we should communicate the community about this thing. Next slide, sir. And there is a one case study which I just want to show you is for June 2005. There is a Parichu Lake outburst in Spiti Valley, and for which you will see how this Parichu Lake outburst has created a scenario of disturbing the sustainability of this region. Next slide, sir. This is located Parichu Lake outburst lake, and Parichu basically is in Tibet, China region, and some of the after flowing into some kilometer, it reaches to the Sumdo, where we have our establishment, military establishment, and it joins the Spiti River system. And because of this outburst, the whole Parichu and Spiti River system was very much disturbed, and too many landslides, Lolo landslide, lake outburst flood, and so many damages of road network we notice in the area. Next slide, sir. So this was the aerial change into the this Parichu Lake, and in 2005 this lake got burst, and water discharge was so high that near Khab, where the water level measurement instrument were there, it was washed away after reading certain amount of discharge. Next slide, sir, please. You can see here, this is the location of Sumdo, and the military establishment was cut off for 2-3 months because of the road, 4 to 5 kilometer of road from Sumdo to Salkar was completely destroyed, and so they started going by developing a new trekking route to fetch some of the life support system or some of the materials from the Sumdo. Next, sir. This was from my village, one of the village that is known as Leo. I visited this village, stayed in one of the house for one night, and I took this photograph, the first one from the wall of hanging wall photograph of that house, and the next one was taken by me, and you can see that the red portion was totally washed away. The whole habitation was washed away, but there was no human loss because the China predicted it nicely. The when the outburst is going to take place, and they given us the information, and the government of India acted swiftly and evacuated the whole population of the low river valley, and so there was no human loss into this, but there was damage of crop, and there was damage of road, bridges, and all. This definitely disturbing the livelihood, and the whole area was cut off for 2 to 3 months from the main area, and so the crops they stranded into the field, and basically the farmers incurred a big loss into this at this time. Next, sir. So we mapped where we have this water hazards and what are the effects. So we came between Sumdo to Poo, between Poo to Kharo, and from Kharo to Jhakari. And the Jhakari Napta Jhakari hydropower project was shut down because of the siltation and mud in the area in the reservoir, and so the turbine cannot run at that time, and so for 3 to 4 months there was complete shutdown of the hydroelectric power project. Next one, sir. So the Sendai Framework for Disaster Risk Reduction 2015-30, there is one goal which says that to attain the expected outcome, the following goal must be pursued to prevent new and reduce existing disaster risk through the implementation of integrated and inclusive economic, structural, legal, social, health, cultural, educational, environmental, technological, political, and institutional measures that prevent and reduce hazard exposure and vulnerability to disaster, increase preparedness for response and recovery, and thus strengthening resilience. Next one. And this can be possible by looking into the three aspects, which uh, which is the exposure, sensitivity, and adaptive capacity. If we can increase the adaptive capacity and minimize or reduce the sensitivity and exposure, definitely we'll move towards achieving the sustainability in the area. Uh, Next one, sir. So in conclusion, I can say that the climate change induced snow cover decline has been noticed in the Himachal Himalaya, resulting into formation of glacial lakes in the region. The glacial lakes in the region are showing increase in the aerial coverage, leading to increase in the potential
हाँ
threat
सर
to the region in form of GLOF. The devastating impact of GLOF in the
हाँ
region
हाँ
is long lasting, which demands proper community level as well as
नहीं
administrative
हम आपको
measures.
पैनलिस्ट बना
And,
देंगे कर लेंगे
and participatory GIS
थोड़ा सा
can be
सर आप 2 मिनट में
improved
इनका खत्म हो जाएगा आप 2
for
मिनट टाइम
inventing
ठीक है
glacial lakes. So next one, the next slide. Next slide, please.
हाँ हाँ लेक्चर कर दीजिए सर बस इनका खत्म हो गया ठीक है सर जस्ट 1 सेकेंड हम आपको पैनलिस्ट बना देते हैं
So
ओके
the
सर
participatory GIS can be the effective. Next one, sir, please.
ओके डॉक्टर
These
साहब
are some of the
खत्म कर लीजिए
next slide. Thank you very much, sir. Next slide, please. Thank you so much for listening me. And if you have some question and query, you can share.
लेट मी चेक इफ एनी क्वेश्चन आंसर इज देयर और नॉट one question, one gentleman asked, what is the characterization of glacier surge? Dr. Pankaj Kumar, could you please answer him? What is the characterization of
Basically,
glacier surge?
characterization of glacier surge. Because of the we use the basically remote sensing data and temporal data we take, and then we monitor how the glaciers is behaving. If the spur of the glacier is increasing year by year, then we can say that the glacier surge is taking place. The total area or the volume of the glacier is increasing. Mass balance of the glacier is increasing. Then we can say that the glacier surge is taking place. Otherwise, if the mass balance is coming down, definitely it is a sign of retreat of the glacier.
And one more person asked that how much is being reduced year-wise from the glacier? How much?
That is a very it's not that you can predict 100% accurately, because we have the data sets that and according to data sets, the results can be vary. I'm using the Landsat 30-meter resolution. Another one is using the Modi's data sets where high resolution is coarse. Another one is using maybe 2-meter resolution. So depending on that, the this trend is also the rate of retreat is basically it can vary, but definitely we have to see basically the sign and signals, and that is important one, that the retreat is taking place, global warming is there, glacial lakes are forming, glacial lakes are becoming danger. Those are important things, and then we have to take into them how we can minimize the vulnerability risk by looking into the sensitivity, exposure, and adaptive capacity. Thank you, sir.
Okay, thank you, sir. Thank you very much. And one or two small questions I will share you, then thereafter I will answer that. So this is what Dr. Pankaj Kumar said. Very nice presentation. Now, keeping in view the paucity of time, so please bear us. We'll go for the second lecture. Dr. Kulkarni is with us. He is here. Now, Kulkarni sir, could you hear me? Hello, Kulkarni sir. Hello, could you hear me?
I can hear you. Yes, I can hear you. Hello.
Yes, sir. Good morning,
yes.
and nice to see you after long.
Good
So a lot of
morning.
problem was there. So finally, our Professor Kulkarni sir is with us. So
Yeah.
he's a very busy man. He's an eminent glaciological scientist. He's with us. Of course, he faced some problem. So, sir, shall you allow for 2 minutes for the introduction, or you can start that your presentation? Is that for you?
Okay. But I don't have access to share. That is the problem. Still.
Okay, sir. Then please allow me. I'll put your introduction within a minute. Okay, sir. So, dear participant, that Dr. Anil Vishnupant Kulkarni is a distinguished scientist at Divhecha Center for Climate Change in IISc Bangalore. His glaciology and cryosphere science journey started from 1979, where he joined Space Application Center, SAC, Ahmedabad. His career took shape as a scientist in SAC, served more than 30 years. He acquired a post-graduation degree in applied geology from University of Roorkee, now which is the IIT Roorkee. So in 1987, he was awarded Commonwealth Fellowship at McGill University, Montreal, Canada. He obtained master degree in geography, followed by a doctorate in geology from Shivaji University, Kolhapur, Maharashtra. Dr. Kulkarni has developed a vast number of remote sensing based methods and models to understand the Himalayan cryosphere. The methods are widely used to date to map seasonal snow cover, glaciers, and moraine dam lakes. So the model used for glacier mass balance, snow albedo, steam runoff, and understanding the influence of climate change in the Himalayan cryosphere. His investigation provide information about the distribution of glacier in the Himalayan region, the changes in glacier area, and dramatic impact of climate change in the Himalayan cryosphere. The Indian Institute of Science, Dr. Kulkarni, and his team developed a model based on velocity, slope, and flow law to estimate the distribution of ice thickness. The technique used to estimate the distribution of ice thickness of thousands of Himalayan glacier provides a better estimate of glacier stored water. Dr. Kulkarni and his team have used a combination of glacier mass balance and climate model in different to understand in different emission scenario, indicating the threat to water resources high uh, under high emission scenarios. He published around 120 papers in prestigious international national journals. These contributions make Dr. Kulkarni one of the leading authorities and recently identifies in top 2% of researchers worldwide in geological and geomatics engineering. Dr. Kulkarni conferred with prestigious national award, Polar Science and Cryosphere in 2014 and the National Geoscience Award in 2009 to recognize his outstanding contribution to applied geoscience. He has also received a Team Excellence Award in 2008 from Indian Space Research Organizations. So this is what our eminent scientist is with us in front of you. Now we are very much pleased that finally we could get him and we will hear him also nicely. So with this, I request Kulkarni, so please take the stage and you can go ahead with your blessings or with your whatever you want to share regarding the glaciology field. Please, sir.
Thank you, sir, for your very kind introduction. But I don't have sharing. Sharing is not allowed from my side. Is there anything?
Just 1 second, sir.
Okay, yeah, it is there now. Let me share my presentation. Oh, let's see, whiteboard, file, anything. How it works on this window. How it works, I don't. Okay, all right. Is it getting shared now or
No, sir, it is not coming. It has to come.
just to come 1 minute? Right. Is it there now?
No, sir, it is not coming.
It's not coming. Yeah, today looks like very. Supposed to be there. Sure it is. Yeah, come, I mean, just this. Huh? What is that now? Oh, yeah, what I can do? Share?
No, sir, nothing is visible. Once you please kindly close it, again you start
Huh?
pressing.
This one? This one, no?
Yes, fine, sir.
Fine. So now, what? That's it? Huh? This again. Okay? Hmm? Okay,
Yes,
all
sir, it
right.
is in Zoom.
Is it there?
Yes, sir, it is nicely coming.
Yeah, okay. Thank you very much. And my sincere apologies for this mess because probably today is the day when whatever can go wrong has gone wrong. And because of that, finally I could make it. It's very nice. So Today I will talk about the state of the Himalayan crust here, that how it is and what kind of issue. So we already know that Himalaya has a large extent of the glaciers. But remember that this is, I really wanted to give slightly different message today, but since the place where I have stored my presentation is not, this computer is not working. Therefore, this is very anomalous to that I am giving a lecture today. So bear with me if there is a little bit here and there issues. But so what we already know that Himalaya has a large extent of glaciers, and the glacier inventory carried out by different institutions in India, just like ISRO, or carried out by Geological Survey of India or outside agencies, suggests that there are approximately 40,000 square kilometer area in the Himalayas, and out of that, 29,000 square kilometer area Indian Himalayas. And now there are numerous ways people have tried to convert that area into the volume, and the Indus Basin has largest volume of glaciers, which is glacial store water, which is around 2,100 cubic kilometer. Ganga Basin has around 600 cubic kilometer, and Brahmaputra is around 900 cubic meter. So that is the store of water in there. But in addition to that, there is also large seasonal snow cover into the Himalaya. So there are, even though seasonal snow cover is easy to map, but it is very laborious work for anyone to do. Therefore, there is not enough literature available on snow caves. But you can see that in winter, if you look into the entire Himalayan mountain range, are particularly these three basins, Ganga, Brahmaputra, and Indus Basin, around 1.59 million square kilometer area is covered by the winter snow, and so it is approximately 85% of geographical area, which is in Himalayan terrain. I don't mean Ganga Basin we include into the Gangetic Plain or peninsular part of Himalaya, India, but Himalayan terrain is 85% is covered by snow, and it comes down as low as 15%, 10% in summer. That means there's a large variation is taking place in snow cover. That winter it is 85% and summer it is 10%. So in addition to that, it is also important for us to understand how much is snow and glacier melt contribute into the stream runoff. So you can see that if you start from the Indus Basin, which is in the, let me check the point. So if you go into the Indus Basin, very high altitude of Indus Basin, you have very large concentration of snow and glacier melt comes. It is as high as 75%. It comes. If we come to the downstream, it significantly reduces, and it can be between 15 to 30 or 45% in Indus Basin. In addition to that, as you move from west towards the east, there is also significant reduction in contribution of snow and glacier melt takes place. And in Brahmaputra Basin, it can go a certain part of Indus Basin, it can go as low as 10 to 15%. But it is important for us to understand that the rivers which are originated in the Himalayas, depending upon what place you are going to make, its contribution can vary from 75% to 10 to 15%. So in an overall, if you look into the Indus Basin, there's a 60% contribution by Indus Basin. In Ganga Basin, around 20%, and Brahmaputra Basin is around 25% contribution is there. So in a sense, it is very significant contribution by considering the dependency of people on this water. So we have to realize that Himalayan region is significantly changing in a sense like it has it is warming, and it is warming much more higher rate than other parts of the peninsular India. So you can see that this is a diagram prepared by Indian Institute of Tropical Meteorology, IITM Pune, in his recent report, which was published in 2020, suggests that early 50s, 60s, and 70s, Himalaya was much more cold than peninsular India. And 80s and 90s, Himalaya is much more warmer than the peninsular India. So what it means is Himalayan region is warming much more higher rate than, than the other parts of globe. In addition to that, there is also some amount of anomaly in precipitation. It means in Western Himalaya, there is a positive anomaly of precipitation. Certain parts of Ganga Basin and lower parts of Himalaya reaches of Indus Basin, there's a negative anomaly of precipitation, and there's a significant negative anomaly when it comes to northeastern Himalaya. So those changes are taking place into the mountain, and the Western Himalaya, particularly if you see, the rainfall component has gone up and snowfall component has significantly reduced, clearly suggesting that there is certain regions of Himalaya has a change in precipitation pattern. It means the rainfall is increasing, snowfall is decreasing, temperature is also changing, and because of that, Himalayan cryosphere is changing. And as the changes in Himalayan cryosphere takes place, we try to understand those changes on the basis of its mass balance. This is a new technique which is developed at the Devija Center for Climate Change, where we can estimate the loss in a glacier mass by using accumulation area ratio. And you can see that particularly for a year 2000 to 2012, which is a time period of a year of time, Himalayan glaciers have lost significant amount of water. That means the glaciers in Satluj Basin have lost almost 16%, Beas in 17%, uh, Chandra is 10%, and Alaknanda is 8%, and Bhagirathi has lost around 6%, clearly suggesting that a significant loss in the glacier mass is taking place. And as a result of that significant mass, glaciers everywhere are retreating. So there's a standard hobby in India which suggests that Himalayan glaciers are not retreating, but they are indeed retreating. And those of you who are still confused about the glacial retreat, you should be quite sure that glaciers are indeed retreating. And they are retreating for a pretty long time. But here you can see it very clearly how this is the Pindari Glacier way back in 1936, how much glacier was big, how big it is, and that has completely vanished now by year 2006, and only small portion of glacier remains there. So you can really understand how we know that by photographic evidences and other evidences, the glacier length is changing, and that length is changing quite. In an average, if you look into the glaciers in Brahmaputra, Ganga, and Indus Basin are retreating in approximately 15 meter per year. Remember, this figure is very important because sometimes you tend to do the work satellite-based images, depending upon spatial resolution. You have to use the time duration for which you can monitor it correctly. So you can see here, this is the data which is plotted here. So all this, whatever you see, the rounded dots clearly suggested that for these glaciers, we have a data of retreat. And the retreat data on various ways it is there. It means sometimes it is based upon field investigation, purely field investigation. Sometimes it is based upon satellite images, but people have gone into the field and verified it. We have only taken all those glaciers where there is a field verification. We have not selected glaciers which is purely based upon remote sensing. So so that is what methodology we have adopted, and clearly suggesting that the glaciers in Ganga Brahmaputra basin retreating. But you can also see particularly in Karakoram mountain range, there is a less retreat compared to other parts of Himalaya. We try to visit those issues. So this is the one of the key issues which we have to understand. But another issue which I wanted to talk is about, it is not about how glaciers are retreating now. And we have seen from that imagery that glaciers are, particularly in Karakoram mountain ranges, are retreating in much lesser rate than any other parts of the Himalaya. And that is the issue which we would like to address and see that. And how that is going to change in future is also very important for us to understand. So this is a CMIP data which is plotted particularly for Himalayan region. And you can see here that so you can see here that how temperatures is going to change under different scenarios of RCP. RCP means representative concentration pathway. So there are numerous pathways. So here you can see that RCP 2.6, RCP 4.5, 0.6 and 8.5, 8.65. 8.5 is the extreme case scenario. That means glaciers are expected, or Himalayan region is expected to rise temperature much more higher than. Or you can always say it is a business as usual. That means if global community keep on living the way they have lived since the Industrial Revolution, they continue to live like that, then there will be a significant increase in temperature. So what is expected is by 2030, the temperature rise will be 2.5 degrees Celsius. Under that scenario, 2060 into 4.5 and 2080 to 5.89. If you see whether you use RCP 2.6, 4.5, 6, there is no significant change in temperature rise this technique. But up to 2030, clearly suggesting that Earth has already committed to certain amount of increase in temperature. The changes become quite apparent by 2060, and you can see from 2.34 to 4.1, and it is significantly much higher in 2080, which is 2.27 to 5.89. So you can see here that how Himalaya is going to warm up, and then you also has to realize that what is the how Himalayan glaciers are distributed in this part of Himalaya. So we have tried to group into three climatological areas. That means you take this as a Karakoram mountain range, you take this as a Western Himalayan, you take this as a Central Himalayan mountain range, and you take it as a Eastern Himalayan mountain ranges. So you can see that one thing you can notice, this is the elevation versus altitude graph of all glaciers, which is because you can do it in these days essentially because you have a layer of glacier and you have DM, you can write some sort of programs to get how much the area altitude distribution of the glacier. So you get here that distribution and you see one thing that the peak, if you take the red color, which is the peak of the glacial distribution, which is around around 5,200 to 300 meters. And if you go into the Karakoram, which is the green in color, you can see it is much higher, which is 5,700 or 6,700 meters like that. So this variation of 500 meters is quite crucial in developing model and understanding how glaciers are going to change. So look at this figure. So we have used the accumulation area ratio model to understand how glaciers are going to behave in future as well as how glaciers are behaving as of now. So you can see here that in a Karakoram mountain range, if we apply this model and try to understand its mass balance, you can see that this is the region year 2000. That means as of now, the model started to function on year 2000. So glaciers have slightly positive mass balance. You can see here. That is why current data, if you look, Karakoram glaciers are not retreating in higher rate of retreat is low. And that is essentially because it has a relatively positive mass balance. If you look into the as a present scenario in Western Himalaya, they are losing almost 200 millimeters or around 20 centimeters water equivalent per year. It is slightly higher in Central Himalaya. They are retreating and they are losing mass around 500 or millimeter, that means 50 millimeter, 50 centimeter per year, half a meter per year. And Eastern Himalaya is much higher. So they are losing at the rate of 800. So it is really very bad in Eastern Himalaya. So what it really means is that if this climate change, the temperature rise continue by 2030, 2050, and 2080. And here we have plotted two scenarios, RCP 2.6 and RCP 8.5. So it means that the situation in Eastern Himalaya is really worse. That means whatever scenario you use, whether you use RCP 2.6 or RCP 8.5, glaciers are significantly going to reduce its mass, and there will be many glaciers which are located in low altitude region will vanish, and there will be significantly reduced in glacier area by the end of century. No matter what you do, probably Earth has committed to do that right now. And Western Himalaya, if you come here, situation is slightly better. That means that if we follow the path of RCP 2.6, then you have some hope. That means that there will be a significant reduction in glacier area. There will be a low altitude glacier will join, but high altitude glacier will be there, even though its area is significantly reduced. And if you come into the Central Himalaya, similar situation will also remain in Central Himalaya. That it's quite possible for us to have some glacier, big glacier, some glaciers located high altitude will remain there, but its area will be reduced. Particularly if you follow the RCP 2.6. If you follow RCP 8.5, then of course we are heading towards the hot finish, whether in the Western Himalaya, Eastern Himalaya, or Central Himalaya. Under RCP 8.5, looks like most of the glaciers. But Karakoram is a completely different ballgame. Look into the Karakoram. So what it means is that as of now, we have a Karakoram anomaly. That means everybody calls it as a Karakoram anomaly. It means the glaciers are not retreating and they are relatively stable. Come by 2030, it looks like it will have negative, but slightly negative, and you might have still stable condition. But 2050, no matter what you do, they are really started to lose this mass quite significantly, and the Karakoram anomaly will probably vanish by the middle of century. And then if you really continue to have RCP 8.5, then there will be a major glacier may be taking place. So many people say particularly in the Indus River basin, where is the additional water is coming. Actually, great melting Karakoram has not even started. Hold your breath, it is going to come slowly. That glaciers are not melting in Karakoram the extent they are melting in Western Himalaya, Eastern and Central Himalaya. So this additional flow of water, which is expected from the glaciers, are likely to come within the next couple of decades. That is what this model suggests. So we will we will look into slightly. Let me see whether I have these figures. It's like I don't have. So we will look into a slightly different issue, what it can do. There are different models. We will not go into these models, but we will try to address that. We have looked into Himalayan mountain range as a whole, but we can look into what is really going to happen to the some of the regions which are located into the Himalayas, which is very near to us. So we are talking here about Satluj Basin, and which water is mostly coming towards the India, and we are using that water. So you can say that under RCP 8.5 scenario, if you see that in Satluj Basin, 55% glaciers will disappear, and and in end of century, almost 97% of glaciers will disappear into Satluj Basin, and this is based upon different modeling techniques and other things. This is not a place for me to go into detail into that, but we have gone detail during our training program. And you can see that how much is runoff is going to reduce because of the vanishing glacier in Satluj Basin. You can see here that as of now, Satluj contributed approximately 14 cubic kilometer of water into the Bhakra now. There's an additional water coming from Bias because of the transfer of Bias water into the Satluj. So as of now, slightly more than 2 cubic kilometer is added by glacier base. So approximately 15% is added by 15 to 20% added, and this contribution is going to go up a little bit by the middle of century, and then it will start down. Key question is why this contribution is going to not come down to zero. This is likely to come down to zero, but here we have just added how much that geographical region is going to contribute because of the seasonal snow. If you remove that contribution of seasonal snow, then it will come down to zero. So if you look into the total loss of water for Satluj Basin is approximately 1 cubic kilometer. So that much less water is available. Whether that much reduced water will be compensated by additional snowfall and rainfall is another question which needs to be answered and needs to be addressed. But some of the pictures we have seen that the region where Satluj is located has started to reduce its rainfall. What can also you see is that the melt is going to take place, the snow melt is going to take place much more quicker than today. And that means there is a seasonality of water availability is also going to change. So you can see here that how this glacial mass loss is going to change under this various scenario in Satluj Basin and RCP 8.5. This is going to be up. But it depends upon the model, whether you use GFPL, CNRA model. So there is a lot of uncertainty in model. But one thing you can be sure about it, because this is a graph which is showing you mass loss versus year, and this is how much mass loss in gigaton in Satluj Basin. You can see that this is going to, cumulative mass loss going to go up. And this is under 8.5 scenario, but these two different models. So you can see how much is a large uncertainty in the model. But what you can be sure is that there is going to be substantial loss in glacier area and glacial mass loss. That you can be very sure of this. So there are try to avoid that, all those things. And with this, I think I would like to stop here with this presentation. So like to thank on this. So anything I can stop it.
Yes, sir. Nicely.
I don't know how I can stop this sharing. Stop 1 minute.
Okay, sir. Sir, you are stopping here?
Yeah.
Okay, sir. No problem. So, this is what our Dr. Kulkarni, he says about the mass balance, change in glacier, in mass balance in Hindu Kush Himalayan region, and temperature and precipitation, how it is giving the impact. He has shown some equation and balancing in details. So he has contributed, he has still in this age, he is doing a lot of research on Himalayan glacier and giving the new findings to the Indians. So what he shared with us, what is the present status in the cryosphere, present status. Now let me know, sir, if at all any question is there, then I'll request you, sir.
Yeah, I will take question. I will take questions if there are any.
One question is raised by Mr. Ram Singh. That is, what is the characteristics of preventing glacier from melting?
How we can see in order to understand what are the characteristics of preventing glacier from melting. So, how to prevent glacier from melting? Let me rephrase this question. So, it is, it is really a see glaciers. We have to realize one thing: are located in a very in a terrain where it is not easy to go physically and do the investigation. Anyway, if you want to, there are a couple of ideas on which you can work. First idea is a global scale. Yet it means that we should control the emission, carbon dioxide emission we are doing into the atmosphere. That means humanity has to live responsibly. Because this is a typical global problem, but people locally are going to experience it. So it is very important for us to realize that is some sort of global action is needed to save the glacier. Now, suppose any glacier is very important for you, or any you want to save it, there are some engineering techniques. But before that, you have to understand how glaciers move. Essentially, glacier melts because of incoming solar radiation, which is absorbed by the snow and ice, and it melts. That is the fundamental. Now, albedo of snow is very high, and in that matter, albedo of ice is relative. We are fortunate in Himalayas that most of the Himalayan glaciers are covered by debris. And because of the thick debris cover, glaciers ice, which is below the debris, is relatively protected. However, a recent study suggests that this cushion of delaying melting may not last long because the distribution of debris on the glacier is uneven, and because of that, there's uneven melting, creating water ponds on the glacier ice. If you have a water ponds on glacier, right, it can absorb the radiation and enhance melting in much more higher rate. So it can delay the glacier mass loss, but it may not delay sufficiently enough for us to take a comfort into it. Now another question is what else you can do? What else you can do is you can now model the glaciers and know that how much glacier there's the equilibrium, the concept of equilibrium line. What should be the equilibrium line so that glaciers will not retreat? We can do it, and if you can artificially spray the snow in higher altitude, it will protect glaciers and you can have a mass balance, which is a healthy one. There are some examples of that being done in Swiss Alps, where people think this is very important for them for commercial purposes. So you can do it. But this can be done for 1 or 2 years. I don't think there is really much scope for us to um, really protect the glaciers on a larger Himalayan mountain system without protecting or without control, without somehow getting handle on climate change. Any other question?
Okay, thank you, sir. Very nicely you have elaborated. Even not only that question, several questions you have answered for that. Still, then that gentleman has asked one more thing. Obviously, that this answer, what is there, what I feel it is, what you explained within that. But still, then, sir, I will highlight you. How are glaciers affected by?
Yeah, so glaciers are affected by. So, what is the global warming? What it does? Global warming, it does. Global warming has a many facets. So, in a context of glaciers, what it means, it increases the temperature. Uh, and if you see in my presentation, as warming or warming phase starts, the mountains which are located in high altitude has a much more warmer temperature than on the sea level or lower levels. So as temperature is higher, uh, then there's more energy available to transfer from atmosphere to ice. And because of the transfer of energy, whether it is in the form of radiation energy or whether it is in form of turbulent energy, it gets transferred from atmosphere, ice and snow, and it accelerates its melting. And as it accelerates its melting, it becomes a negative mass balance. It means that glaciers do not have enough ice to push forward and bring it towards the terminus. It means that if there is no enough glacial ice flux coming towards terminus and the melting rate at terminus is higher than incoming flux, glaciers are going to reach. That is what happens. And another key parameter is precipitation in a global warming. What also happens now, due to the higher in temperature, the regions which usually get the snowfall sometimes started to get the rainfall. I don't mean all the time, but it is quite possible, and many of us who have gone to glacier have seen that it is possible to get your rain it onto the glacier ice. That frequency increases, and as water falls onto the ice, it tries to refreeze. It is exothermic reaction. It gives additional energy for snow. So all those things lead towards the more negative mass balance, more glacial. I think that is what global warming does to the glacier.
Yes, sir. Nicely elaborated. Very good answer. That global warming can give the only the negative impact. Now, keeping in view of positive time, we'll go further. Thank you very much, sir. Irrespective of a lot of hazards you have faced, still then you are in front of us and you have shared your knowledge. So thanks a lot. That some questions are coming, I will send it to you, and I'll accordingly after receiving the answer, I will send it to them. I know that, sir, you are having meeting, obviously, but still then you have kept your promise. And
So because of some issues, I could not come beyond my control. So I hope we can do much better next time. Okay.
Okay, sir. Thank you.
Thank you. Thank
Now,
you.
gentlemen, participants will go for the third. That is, we'll go for the third presentation. That is by Mr. Anil Kathayek. He is with us. Mr. Anil, you are here.
Yes, sir, I am available here.
Okay, very good. Nicely, nice. So, Dr. O'Neill will share his views about the Himalayan region in the glacier and in that scenario. And I hope the participants, most of them are familiar with him. Still, then a brief introduction, I'll say just that Dr. Anil is he was our junior consultant at this NIDM, and presently he is working. Presently, he is working in that CDC, that is as a technical officer, EM, VHS, CTC, India, and presently he's posted in Delhi. And earlier he was with us, and he was involved in the Center for Hill Area Development, Geometeorological Risk Management, and National in this institute. And he was the postgraduate in geosciences, especially in geology, and with his over more than 10 years of experience in the field of landslide hazard management and disaster management, he has done a lot of publication. And prior to joining NIDM, he was worked with some prestigious organizations like UNDP, NIUA, and CRRI. He penned more than 25 research papers on various aspects of landslide hazard mitigation management. Inter alia contributed in drafting in engineering guidelines on landslide mitigation measures in Indian road. So with this, may I request Mr. Anil to go ahead with your presentation, please. Mr. Anil, over the stage to you.
Thank you. Thank you very much, sir. I request you kindly assign me the sharing privilege so that I can share my screen.
Yes, dear, I have shared you, so please.
Okay, thank you very much, sir, for providing me this opportunity and for my introduction. Sir, I hope my PowerPoint is visible.
Yes, it is visible. It is coming. Yes, now it is in Zoom, and your voice is also coming.
Okay, thank you very much, sir. So I will be talking about some of the management options from Glacier Lake outburst flood. So as you know, mountain regions, they are characterized by sensitive ecosystem. They are enhanced occurrence of extreme weather events and natural hazards. They are also reasons of conflicting interest between economic development as well as environmental conservations. So with rapid global warming, our fragile mountain landscapes are evolving, and new threats, uh, particularly like of that of landslides and glacial lake outburst floods. Then we also are facing avalanches now and then, cloudburst phenomena, and that is followed by flash floods. They are also posing serious risk to the vulnerable mountain communities. And as you know, our focus is on Himalaya, which is also known as the third pole of our planet. This mountain range are still rising. They are becoming increasingly vulnerable, or you can say the vulnerability index of our Himalaya is altering because of changing pattern of climate change. So this mountain range are ecological hub. They serve whole nations with its resources, and the world's youngest mountain range, due to of its geological, geomorphological setup and water set. Besides this climate change, they are magnetizing a disaster of different intensity, of different frequency. Like earthquake, floods, landslides, cloudbursts, flash floods. So all these are some of the major disasters which now jolt our Himalayan communities and ecosystems, which is stretched out more than 2,500 kilometers in that covers nearly about 3 million states, and union territories like J&K, Ladakh, then Uttarakhand, Himachal Pradesh, beside the 7 sister states of our northeast. Arunachal Pradesh, Manipur, Meghalaya, Mizoram, Tripura, Assam, and this Sikkim. And this they make up the what we call it Indian Himalayan region, and it has diverse population, versatile economy. It has diverse environmental, socio-economic parameters, and that homes about nearly 50 million peoples. So during today in my talk, I will be discussing two of the major GLOF related disaster that occurred in Uttarakhand states, and what management, what option do we have for managing this mayhem in our mountain covers in this ice cover mountains. So first I saw the Kiltana tragedy that was in year 2013 that caused enormous damage. It got destruction as well as many precious lives was engulfed during this incidents, and the incidents has raised various questions about it raised question about disaster preparedness, it raised question about the mitigation strategies in the fragile Himalayan ecosystems in context of development patterns, and as you know, this region had its great it is known for its tourist sites, and basically that was tourism period this June 2013. And this accident occurred during Char Dham Yatra, which is the busiest season for tourism and pilgrimage, and the rainfall range from heavy to very heavy across the states. And as a result, flash floods, landslides have occurred throughout a large region, and Uttarakhand and the surrounding territory received nearly more than 350 rainfall, percentage higher rainfall than the average rainfall during this regular monsoon at that particular year. So this is the satellite view of the Kedarnath, showing the drainage patterns, glaciers, and lakes along townships. And when you come to the impact of that tragedy, so it had a great impact on the ecosystem, on the communities of the this Himalayan states. So, and overcrowding in the name of tourism, it only added the strain on the Kedarnath. So this snow-capped mountains and this rivers that Mandakini and sorry, Saraswati that surrounds Kedarnath, and the devastating Kedarnath flood, it devastated the whole valley of Kedarnath and other portions of the Uttarakhand during its course downstream, and heavy rain and cloudburst on the enormous glacial lake and the subsequent flash flood, it wreaked havoc on the communities, on the ecosystems during this tragedy in 2013. And the Kedarnath temple, which is located on the on this Mandakini river bank, as well as it also faced the mayhem of this particular incidents. Although it doesn't the impact of this incident was very less on basically on the infrastructure of that temple. More than when it comes talk about the loss of lives, then more than 5,000 people were killed during this incident, and thousands of were injured. The number of this incident also triggered numbers of landslide downstream, and enormous damage to structure infrastructure was also recorded during this time. And it also shattered the tourism sector of the Uttarakhand, which that constitute more than 30% of the state's income. And due to unpredictable weather condition in the region after this incidents, the rescue operation had it become a risky event in itself on, and the rescuer had many difficulties due to the mountain terrain and lack of the accessibility in the majority of the roads. And this event was has such a magnitude that during the rescue and response operations, more than 40 plus responders lost their life while saving the lives of others people. Coming to the Chamoli tragedy that was in the month of Feb 2021. So this was a grim reminder of the 2013 Kedarnath tragedy, which wreaked havoc on the ecological sensitive Himalayan region, and this unlike that Kedarnath, which tragedy which occurred after a violent downpour and the breaking of glacier tragedy, Lake, this tragedy, this Chimoli of 2021, occurred in bright and sunny morning of Sunday around 10:30 a.m. and the area was jolted with a glacial burst triggered tragedy, and the impact of this event was felt downstream up to Chamoli, and according to the witness, a cloud of dust that was followed by flash flood, which consists of enormous debris scattered the area, and within a few minutes. Starting from the confluence of Risiganga and Rontinala to downstream up to Chumali. It was all filled with debris, and this disaster is engulfed more than 200 people. And beside taking the precious lives, this event also swept away the two major projects at that valley region. One was Risiganga Power Project, and other one was NTCPC's under constructed hydropower project that was in the Tapovan area, and it also beside the destruction to this infrastructure, this is the Risiganga Power project. As you can see, this is the image from before the event, and this is after the event. Here you can see the completely buried under the debris by flash floods. And apart from this destructions, it also destroyed 7 bridges in the area, and totally that affected this communication between 13 villages of Josimat Tehsils. And it also wreaked havoc on livestock. More than 150 livestock uh, that consists of small and big one were also buried under the heap of the debris. And adding to the vulnerability, a landslide dam lake was also formed at the confluence of Risiganga and this Ronthi Nala. So coming to the management options for Glacial Lake outburst flood. So we can categorize on like hazard reduction option, exposure reduction option. Like in hazard reduction options, this options it aimed at reducing the hazard uh, often entail structural changes to the glacial lake itself, and with the goal of it's the goal of this option is to lowering outburst susceptibility or lowering the scale of prospective occurrence and lowering the lake level. So that has a direct impact on the lake's hazard potential since it reduces the lake's capacity and on and also increase the this which is reducing the capacity of this lake will also help in reducing the vulnerability to the downstream communities, and the level of this lake, it can be of that any particular, it can be decreased in the short term and in any emergency by various methods like siphoning techniques or pumping techniques. And the efficiency of such attempts, it is determined by the, it depends on the characteristics of site characteristic as well as the access to the lake and the ability of this pumping equipments and the experience. Of course, to carry out this options, we need experienced persons should be engaged. And another option is control blasting. Control blasting can also be used. It can be used to breach the lake with control, and it reduce its option to be a disaster to downstream communities. Another thing for management of glacier-induced hazard and risk is we can go for the exposure reduction options. Exposure can be decreased. It can be in the for short term by evacuating the people in the event of any emergency, or for long run. We can consider hazard maps for all key process when planning spatially. And so constructions and development restriction, we can restrict construction and development in basically in the Glacial Lake outburst flood prone areas. So basically this land use and planning, it is an expensive and effective way to mitigate risk of any particular hazards by avoiding the hazard and minimizing the risk. So land use planning is the most effective and cost efficient approach of lowering the losses. And in GLOF prone areas of our country, there are commonly no acknowledged procedure, or you can say there is no regulation for land use planning. So we need to focus on deployment of such strategies for such land use planning regulations for basically for the area which are prone to this glacial leak outburst floods. And we can also go for the options where we need to reduce the vulnerability reduction options. And only in this long-term vulnerability can be decreased. And vulnerability, it should be reduced or removed based on the vulnerability assessment. So first we have to go for vulnerability assessment, and capacity building with vulnerable population is also a critical activity for reducing the vulnerability of them to any impending disasters. So it has basically it has a beneficial impact on most the risk management strategies. This particular capacity building, it should be result in a more comprehensive awareness of any phenomena or climate change or and its consequences on a regional or what will be the its consequences on local level. So it should also consider this cultural and traditional factor, as well as local awareness of environmental changes and knowledge of how different hazards are seen and prioritized. It is useful for choosing site-specific and appropriate risk management approach that will approve. We also need to take views, the opinions of local communities, and they better know their place than the some outside persons. Awareness, we also need to focus on awareness drive for specific groups, including communities residing on the downstream areas, on vulnerable people like women, children. Basically, when any disaster, they are seen as the sections of community which are more vulnerable, rather besides the other sections of the communities. And we also need to focus the awareness drives for the senior citizen, for the urban planners, for the architectures and other line departments like geologists, civil engineers. They should also be undertaken. And administrative integration among the government departments and public sectors, NGOs, civil bodies, it should be given special attention to integrate activities related to creation of awareness and preparedness. As you know, disaster management, it is the field of multi-dimensional and multi-stakeholders. So it is not only the responsibilities of any particular department, but all the line departments have there some role to play in the management of any particular disasters. And in order to design action plans to promote awareness and preparedness measures to final mile, a comprehensive and collaborative approach to training to awareness deployment, it should be considered. And this for capacity deployment, as you know, this GLOF hazards and threat, it initiate a full understanding of natural process and their complex interconnection in the glaciated high mountain regions, as well as the knowledge of historical and future changes at various spatio-temporal scales. So technical skills must be combined with the skills. So we need technical skills, and at the same time, we also need the local traditional knowledge about that particular region. So we need to focus up on the educations of professionals, where as you know, this and GLOF are most likely to harm glaciated areas and mountain range. As a result, knowledge exchange and experience sharing amongst on the researcher, the scientists, practitioners who are working in the field of glaciers related things, glacial later who have glacial later concerns. So all should be come under a single umbrella to share their experiences, to share their expertise. So, and apart from education or professional, we also need to enhance the awareness of community by, and for that, community education is important. Building capacity in community, it could be affected. That's GLOF, this glacial lake outburst flood. It is also critical that we need to enhance the capacity of a community that are affected. They are living in the glacier prone, GLOF prone areas. So we need to circulate the information on the reason, the causes of potential risk, the causes that are putting those community, their ecosystem to the potential risk window of glacial lake outburst first. So local communities should know the reason, the causes, what are the current situation and the potential scenario of any outburst event in the future, including the expected impacts of at different sites relevant to the community, the current risk situation, and potential scenario of outburst events, and including the expected impact at different site relevant to this community. So education and awareness raising also needs to extend to reach this population, the community that are prone to various hazards, various risks of any glacier related components. And apart from this local community, we also need to develop education and awareness materials to tourists who visit these places for recreations. So apart from local community, we also need to focus other this pilgrimage of that particular area. So this could be achieved for we can go for information science, we can develop infographic for tourists who are visiting such area that are prone to this glacial lake outburst floods. We also need to focus on the research and development in case of any high hazard or risk levels, targeted monitoring, employing advanced space-borne and terrestrial technology. It is essential, uh, as our Prime Minister also highlighted, that we need to this modern science and technology should be leveraged for reducing the risk of disasters. So we need to think how we can utilize the power that is given by this new technology in the monitoring of the hazards of glaciers. And also this component regulation and their enforcement, it is a critical one, a techno-legal regime focusing on urban, rural area located the downstream, basically the downstream of and this glacial lake outburst flood hazard in the Himalaya is necessary to prevent future developments in the hazardous area and protecting the exiting one. As you know, in our country, in India, there are no commonly acknowledged methods or regulation for land use planning, basically in the glacial lake outburst prone areas. So we need to we need to outline the specific land use zoning, development control, and building constructions laws in the in such danger areas which has danger to this glacial lake outburst flood events. So and there should be a single legislation to control development and building activity, which could be formed as in by taking into consideration present legislative framework and incorporating the suggestion made, and it should be followed strictly. The provisions of this land use this regulation provision should be followed strictly, and the regulation should make it mandatory for all buildings, especially the hospitals, schools, and community halls, to be designed according to the latest specifications and this codes. So coming to the what we way forward from here. So we need to go for reassessment of the vulnerability of the area, particularly when you see the Chamoli disaster of 2021. That event was the major one after the 1970 flood, after the flood of 1970. The event of Chamoli disaster in 2021, it was the major one. So no one has any clue of that disasters, as it was a sunny morning. So no one has any clue, but never think such a thing will be happen. So there is need to reassessing the vulnerability of our Himalayan states for such events, and impact of climate change on the huge ice mass, and we need to study what will be the impact of these changes on our snow covers. And there is also need to understand the impact of climate change on the glaciers, and what are the impact of other disaster as well, like earthquakes. What are the impact of earthquakes on this ice bodies, and adoption of sustainable development approach or development, as you know, it is inevitable, but at the same time aspects of long-term development are just as crucial. So we need to focus on development without restrictions, and education and awareness raising. We also need to extend to reach the people who might be who are living in the glacial lake outburst flood prone areas. So globes and other connected hazard, it must be educated. Local community must be educated and more widely known about the probable causes, what are the probable causes of such incidences, and what measures they can adopt to save themselves, to save their this belongings from such disasters. And this um, specific land use zoning, development controls, and building constructions laws. We need to develop them. We need to there should be a single piece of law to regulate development and construction activities, so that all the structures should be required to meet that more recent. That we also need to focus that all the structure that will be developed in this vulnerable areas, they meet the most recent specification and requirement, and they are according to the regulation that fits to that particular area. So with this, I conclude my talks, and back to you, sir.
Okay, thank you, Mr. Anil. Very beautifully you have explained about the GLOF, and also you have highlighted the what are the management options. And this is very required in the present context, and hazard, how the hazard could be reduced. And certain options you have also highlighted. Nice thing that siphoning techniques is required, and also control the blasting. Blasting should not be there in the hazard terrain, especially in mountainous terrain or in the Himalayan region. And also, you said the exposure reduction option, the evacuation technique or evacuation measurement or evacuation option, it has to adopt whenever, as and when required. And also a lot of things regarding the awareness drive you have said, very beautifully you have explained. Capacity development also, the community in that area, they should be imparted for the training. They are the first person in that area for the rescue operation and for keeping the people in safe. That community should be make them some capacity building for them, and also the educational professional, different educationals, I mean experts are there. They are already they are having the similar kind of knowledge. Still, then we have to impart training for them, and regulation enforcement and informants are there. Beautifully, you have explained to our participants. Thank you very much, Mr. Anil. And now let me see if it is there any question.
Sure, sir.
Okay, Mr. Anil, so far I could not see here right now. And if at all it will come, I will let you know. Accordingly, I will reply to them. Now, this is our aim for the successfully have completed 3 lectures by the eminent speakers on GLOF. What is the present day's scenario in Himalayan cryosphere, and what are the precautionary measures we should take. That last speaker, he had given a glimpse of that. And so it is a successful for that in the GLOF. Again, in future, we'll conduct. Now, without taking more time, I'll put the vote of thanks as a customary. Now, it is our that executive director who is providing us all kinds of support for this type of webinar and training. So I on behalf of NIDM, we are thankful to our this executive director. Next is our head, that is Professor Surya Prakash. All the times he is supporting, though he is out of station, he is busy, but still then for our morale boosting, he'll be joining and he'll put his address to the participant. So sir, I'm thankful to you for this moral support and all the times you are with us. And then the participant, our panelists who are here. And before the panelists, I should say this eminent speaker, that Dr. Kulkarni, he was very busy though, and he faced some technical problems, but he has succeeded. He was supposed to be attending the meeting, but still he has deviated and he has taken some time from there, and he has managed, and finally he has delivered the points. And with his findings in this age, whatever work he's doing, he's sharing to us also. So, and our Dr. Pankaj from Delhi University, that is technical economical university, and also this Anil Kumar, who is our ex-colleague. So beautifully, I'm thankful to all of the speakers. They have, without miserly, they have shared their knowledge, and for the benefit of the public, especially in the Himalayan region, what should we do and what is happening, what are the findings they have shared. So I am very much thankful to all those 3 speakers. Then after that, I should put my thanks to the panelists and who are here to support, to make this webinar success. So I put a big thanks to them. Thereafter, the participants who has given a pleasant, good success by joining and peaceful hearing. So I put my heartfelt thanks to them, and this other staff, that is for the IT and our auxiliary staffs are there. So I put my thanks to them also. So overall, so it is a very good presentation and good sharing and good knowledge and good deliberation. So now it is we'll take the leave again from the 17th, 18th, 19th, 3 days training program is there for our university. There is a capacity enhancement for disaster risk reduction for the Lucknow University in collaboration with Lucknow University, 3 days program from the same time, 11 to 1 o'clock. So I request the participants, you can join if you feel, and a lot of, apart from the natural disaster, that man-made disasters will be covered, and a lot of things will be shared for that. So I put my end here with a big thanks for all of your cooperation so that we can make success for this webinar. So thanks all of you.